Oh, it's 9 o'clock.
All right. So let's go ahead and get started. Okay. Hello, everyone. Thank you for joining us today. This is our first episode of our elementary live learning at home summer 21 sessions on the topic of engineering and sustainability. In this episode, we'll be talking about wind energy and how we can use it to make Earth more sustainable. We're now live on both Zoom and our Engineering Outreach YouTube channel. So just to go ahead and introduce myself, my name is Aaron Emmanuel. I'm working as an Engineering Outreach Program Instructor for Ontario Tech University. And yeah, I just finished my first year of Mechatronics Engineering. I'm also here with Mahum. So if you want to introduce yourself.
Hi, everyone. My name is Maham. I'm also an Engineering Outreach Program Instructor for today. I'm going to be helping you guys out with the activity. And I'm going into grade 12, actually. So a little bit about me.
Cool. So just to go over some ground rules, for individuals watching our live at home learning sessions on YouTube, our sessions are being hosted live on Zoom. If you'd like to participate and interact with us, you can still register in our Engineering Outreach webpage as seen near the bottom of the screen. And for our registrants on Zoom right now, when you join Zoom, make sure you join with your first and last name. Our sessions will be broadcasted live and publicly posted on our YouTube channel. You will not be able to share your video or audio in order to ensure your safety and maintain confidentiality of your personal information. You can interact with us through Zoom's in chat feature, as you can see on screen. You can ask questions and make a comment at any time. However, the chat function should only be used to talk about content relating to the activity, and also ask your parent or guardian if you need additional support. Finally, every participant has a responsibility to promote a safe and positive environment where all participants have a right to be treated with respect and dignity. Let's make a promise to be respectful to everyone in the classroom. All live learning at home sessions will be publicly available on our Engineering Outreach channel at a later date to allow other students to learn from the content and for registrants to re-review sessions. There may be a chance that students may be recorded in the session. If you do not feel comfortable, please ensure that your camera and or audio remain off. And consent to being filmed was completed during the registration process. All right, that's all. Let's get to it. So you might have heard of STEM before, but for those of you who haven't, STEM stands for science, technology, engineering, and math. We use science to help us understand the world around us through experiments. We use technology to create tools and machines to help us solve problems. We use engineering to solve real-world issues and design and build models. And we use numbers, shapes, and patterns to better understand the world. You might be wondering what engineering really is and what engineers actually do. Well, engineers invent, design, build, test, and analyze a multitude of machines and structures to solve problems while remaining safe and cost-effective. Does anyone here know any types of engineering? You guys can feel free to type in the chat so we can see some of your answers. Yeah, mechanical, electrical, software, civic.
Hey, that's software is my dad's job. He's a software
Really?
engineer.
That's cool.
Also mine too.
Very cool, very cool. Okay, so let's go over some of the types of engineering. So first we have mechanical engineering. Does anyone know what mechanical engineers do? Make sure you use the chat.
They fix cars. They fix stuff.
Yeah, that's part of it. Mechanical engineers, they kind of like design generators and engines and also your fridges at home. That's what they like design some of this stuff. So also make sure to use the chat function. But yeah, someone raised their hand. If you can type in chat, that'd be great. They fix stuff, design machines. Yep, I see some of the answers in chat. Appliances, yep. So that's kind of what they work on. Next, we have aerospace engineering. Does anyone in the chat want to type what aerospace engineers do?
They build rockets. This is rocket on screen.
Rockets. Yep, that's a big part of it. Evaluate designs. Rocket science, yes. So aerospace engineers, they work on most of the things that fly, like airplanes, spaceships, and even like satellites that go around Earth. Next, we have electrical engineering. Does anyone here know what electrical engineers do?
They make phones. They make iPads. They make TVs. They
Yeah, basically they
They-
work
they-
with everything electric. Yep, I see in chat as well. Yeah, so they work with like electrical equipment mostly, like motors, radars, even navigation systems. Next, we have computer engineering. Does anyone know what computer engineers do? Software, laptops, they code. Yeah, that's a big part of it.
they code. My dad codes.
Yeah,
Just
it's
like
software engineering. Good job. So yeah, computer engineers, they design computers, hardware, and software through programming, like I've seen in chat. Next, we have civil engineering. Does anyone know what civil engineers do? Buildings,
there was
yes.
structures.
Construction, city, bridges. Good answers, yep, that's exactly what they do. They kind of work on buildings, roads, bridges, airports, all the sort. Next, we have biomedical engineering. What do biomedical engineers do? Doctors, vaccines. Medicine. Yeah, so it's kind of like that, but mostly biomedical engineers, they kind of create like prosthetics and like other medical devices that
Doctors
require
use.
engineering. Yeah. Cool. Next, we have chemical engineering. Does anyone know what chemical engineers do?
They're kind of like scientists, and they make.
Chemistry.
Can they even
Yeah,
make
use
the
they do
vac-
chemistry.
Can they even make the vaccine?
Yeah, so chemical engineers, they kind of focus on chemical manufacturing processes. So they work on pharmaceuticals where they make certain drugs to help with health. They do paper
Vaccine.
where you have to do like mixing pulp and stuff to make paper, and even food processing. And finally, we have mechatronics engineering, which is the one I'm taking in university. It's kind of a wait, does anyone know what mechatronics engineering is? Electronics plus mechanics, yep. Microchips, robots, exactly. Yeah. So mechatronics engineering is kind of a combination of mechanical, electrical, and computer. So we work with mostly robots, things like that, where like phones, robots, all the sort. And yeah. So even though there's so many different types of engineering, all engineers follow a set of steps to help them. And this is known as the engineering design process. The engineering design process consists of 5 main steps: identifying the problem, brainstorming ideas, designing a solution, making a model, and testing and evaluating. After we reach the final step, it's totally normal to go back to any of the previous steps and then go through the process again until we're satisfied with your design. So just before we move forward, does anyone have any questions so far? Maybe on the design process or anything we covered earlier? Maybe say you're good in chat, or if you have any questions. Good. You're a bit late. Well, in the beginning, we kind of just covered some ground rules. So like, make sure you keep your camera and mic off if you don't want to be seen or heard for your safety. That's pretty much it. We also went over the different types of engineering, but I think you were here for that. Cool. All right. So I guess, yeah, so let's say you were designing a solution, right? If you're not happy, let's say you design a solution, you make your model, and then it doesn't work. When you're testing it, it doesn't work. You can go back to brainstorm ideas. You can try to make a different solution, design a different solution, make a different model, and test it again. So after you test it again, if you're happy with it, you can go through and that's your final design. But if you're not happy, go back to brainstorm ideas. Is that cool? All right. I'm gonna go to the next. But if you have any questions, you can type in chat. I'm sure my co-host can deal with it. Okay. So moving on with energy, which is kind of our main topic for today. Energy is the ability to do work. It can move and change, but it can't be destroyed. And energy comes in many forms. So first you have mechanical energy, which is kind of energy that's due to motion or your position. We have thermal energy, which is energy produced from heat. We have gravitational energy, which is energy stored in an object due to its height above Earth. We have nuclear energy, which is like using nuclear reactions to produce electricity. We have chemical energy, which is chemical reactions where you produce other substances. For example, batteries and gasoline, they use chemical energy. Next, we have electromagnetic energy, which is kind of energy that's carried through radiation. So kind of like microwaves or your cell phone or X-rays. Next, we have kinetic energy, which is actually one part of the first one, mechanical energy, which is energy due to motion. And then we also have potential energy, which is the second half of mechanical energy, which is energy due to your position above Earth. Next, we have sound energy. And this is kind of what we see when we hear, or yeah, and you kind of use this in hearing aids and phonographs, where you can like kind of graph sound. And finally, we have ionization energy, which is kind of less heard of. It's kind of the energy that you need to force an electron from an atom or molecule. And when this happens, it like releases a charge, and this charge can be used in like welding work because it's pretty strong and it can like melt metals. But yeah, some welding work uses tools that do this. Almost every form of energy can be converted into other forms. But no matter the form, energy is basically a level of how much work something can do. Interactions produce changes in the system, although the total quantities of energy remain unchanged. For example, a power station produces electricity by changing the energy from fuel into electrical energy. A gas-fired power station burns gas, converting the gaseous chemical into heat. Almost every form of energy can be converted into other forms. But essentially, energy is the capacity for making something happen, or as scientists put it, doing work. And energy comes from many sources as well. This includes power plants, food, light, windmills, fires, even the sun, and so much more. And we use energy in our daily lives, from breaking down the food we eat to heating up our homes. But before we move forward, I just want to, that's a pretty big section, make sure we don't have any questions. Potential energy is the energy in which it has potential to use energy. Exactly. It can be converted and transformed, but it can never be created or destroyed. Exactly. Okay, I think we're good. We'll move forward. In which categories would batteries fit in? Right. So batteries would likely go in chemical energy because it undergoes a chemical process to actually make the batteries work. So there's like a chemical reaction in the batteries. This is also with gasoline because gasoline is created through different chemical compounds. Okay. I'm sure if there's any other questions, we'll answer in chat, but for now, we'll keep moving on. So as I mentioned before, and even in chat, energy cannot be created nor destroyed. And this fact is known as the law of conservation of energy. So in a car engine, there's a chemical reaction that creates energy, and that energy is then changed to mechanical and heat. Trees use the sun and convert its sunlight into chemical energy to help them grow. Electric mixers you use when cooking take in electrical energy and convert it to mechanical energy and heat. And when you hammer in a nail, you convert the mechanical energy into heat as the nail is pushed in. During these processes, no energy is created or destroyed, just changed. An important part of keeping Earth sustainable is reducing our use of non-renewable energy. Non-renewable energies are energy sources that cannot be reused. One example of this is fossil fuels. Fossil fuels are fuels that come from old life forms that decompose over a long period of time. In Canada, we rely on fossil fuels for about 65% of our total energy, and the USA relies on it for about 81%. It's expected that we run out of fossil fuels in just 50 to 150 years. Some other examples of non-renewable energies, non-renewable resources are coal, natural gas, and nuclear power. The reason why we need to reduce our use of non-renewable energy resources is mainly because of the greenhouse effect. Burning fossil fuels releases greenhouse gases, which are basically carbon dioxide and sulfur dioxide. When the sunlight hits Earth's atmosphere, the greenhouse gases are trapped and absorb the heat, which warms our planet. Now, you may be thinking, winter is too cold, so who really cares if it heats up like a degree or two? But in reality, if Earth's temperature increases by just 1 degree, it can cause a lot of damage worldwide. But we can counteract non-renewable resources by using renewable energy. These are energy sources that can be reused, as they will never run out. We call renewable resources clean energy, as these energy sources do not pollute the air or water around it. Currently, only 10% of the world's energy comes from renewable resources. You may be wondering why only 10% of the world is using renewable resources. Well, while we have renewable energy as a solution, we can't use it all the time. Does anyone have an idea why in chat? Yeah, it's not always sunny because costs a lot to get them. It has to be windy weather, the winter. Yeah, great answers. But yeah, so basically, unlike non-renewable energy, we haven't found a way to efficiently store wind, hydro, and solar energy. So when we do need these energies, we have to use them right when we get them. Otherwise, we lose some of it during storage. The process to replace fossil fuels will take too long. Well, yeah, it will take a couple thousand years. That's why we call them non-renewable, because it's not a choice. Natural resources, so that's why they are unpredictable. Right, exactly. Okay, so we'll move on.
All right, so we've been talking about renewable sources, and one of them you guys have already mentioned is wind energy. So we've already talked about energy a tons. So let's check out what wind essentially is. A lot of times you can feel wind, but you might wonder, like, where does it come from? Like, how am I just feeling a gust or a push, right? So wind is essentially just moving air. And a lot of people across the world over time have been using wind to do work. Early Egyptians used the wind to sail ships on the Nile River, and people still use wind to move sailboats. And in Holland, people use windmills to grind their wheat, and the Pilgrims used windmills to ground corn, to pump water, and to run sawmills. Today, we use wind to make electricity. Now, humans have been harnessing wind energy for use in sailboats for many centuries, which occurred before the invention of windmills. And currently, there is a total of about 500,000 megawatts of wind energy capacity worldwide. The largest wind energy nation is China, then the US, and Canada is number 6 worldwide. So, how exactly does wind form? How does it work? Basically, wind or air is made up of atoms and particles. And when they get really excited, they decide to create an imbalance. And how do they get excited? Because of the sun. So the sun heats up their atmosphere, and that causes an imbalance in temperature and pressure between the air particles. And then you kind of have this gush of wind. And through that, you can create wind energy, which is the process where wind is used to generate mechanical power. So we're going to talk about how exactly we can take wind and turn it into some sort of electrical thing. Basically, when you have a wind turbine, you have 3 main parts to it, right? You have the blade, something that's doing the spinning. You definitely have the wind. You have some gears in the back here, but then you have the electrical component. So you have wind power coming through into the blades, and then they will make the blades turn. When the blades turn, that makes the gearbox turn, and all the gears start to shift and move, and that is the mechanical power. That mechanical power will go into the generator and the power interface, which will become the electrical power, and that's basically what we need to heat up our homes. So it's going to go onto power lines and connect to the grids and connect to your home. So that's how you're going to have electricity. Wind lifts the blades and causes them to spin, and this causes the low-speed shaft attached to the blade to rotate, right? So this area begins to rotate. And then inside the drivetrain, a gearbox connects the low-speed shaft to high-speed shaft. So now this is a faster spinning going on. And as the high-speed shaft rotates, it turns a generator, which converts the mechanical energy into electricity. So there are a ton of different types of engineers that are involved in production of wind energy and in using wind energy, right? There are actual engineers called wind energy engineers, and they basically, everything they do revolves around wind energy and wind turbines. But some other engineers also have to collaborate and work together for the same cause. There are electrical engineers, mechanical engineers, and environmental engineers. So electrical engineers, obviously they focus on the electricity side of things. Mechanical engineers might focus on the wind turbines, and environmental engineers will probably focus and think on, okay, this is supposed to be a renewable energy source. So is it actually helping the environment, or is this becoming a problem for the animals that live nearby? Or is the structure not going to stand still here because the ground is just too soft? Things like that. Basically, all these engineers and more collaborate and work together to build and test wind turbines. You're right, Jason. Wind energy uses a wind turbine, and the wind turbine rotates using the power of wind to create electricity. Yeah, basically summarize what I just said. So there are tons of applications and tons of different kinds of wind turbines. Let's take a look at the first one. Have you guys ever seen your traditional windmills when you go out in the country? Anyone? Have you guys seen the one that's to the furthest to the left? Yeah. Nishi says yes. Sharia says yes. Shakti says yes. Exactly. So these are your traditional windmills to grind flour. And they just have 4 blades. They work pretty slow, but they kind of want it to be slow. They don't want it to be too fast. Something you probably haven't seen as much is this one. This is the wind turbine to pump groundwater in Kenya. Oh, you've seen the ones that are using these ones too? The specific one. That's pretty cool, Jason. So yeah, you're probably noticing that this one has a lot more turbines, a lot more blades, has a lot more blades, and it's going to spin much faster. Okay, makes sense, Jason. So yeah, these ones are really cool because they're basically helping a village or a farm pump groundwater out so they can spread it to all their other crops and cattle and things like that. Another one here, this one is very minimalistic. It's a small scale wind power scheme from Peru. This one only has 3 blades, but these are used in villages in Peru where they want to bring more electricity into their area. These next one, I thought this was like really cool because I thought it was so different and unique. This is the vertical axis wind turbine. And the cool thing about this is that it can take wind in any direction. So if you notice, all the other turbines, they're facing a specific way, but the vertical axis wind turbine doesn't have to face a particular angle because it's going to rotate vertically. Yeah. So Jason says that he hasn't seen vertical axis ones or the small scale ones. Yeah, definitely. And that's because of how they're going to be used and where they're going to be used, things like that. There's other types of turbines, which I think is really cool. And these turbines, the road wind turbine, the rooftop turbine, these are kind of important because they're kind of trying to incorporate them into regular infrastructure and wherever there is the most wind. So on the road, when cars speed or just drive regularly on a highway, they're going to create wind. And people are realizing that we shouldn't just let that human-made wind go to waste. We're going to use it. So they put wind turbines above the highway signs so that they can spin and generate electricity. Same thing for the rooftop, but definitely you guys notice that these ones are smaller. So that is good to note. So just like anything in life, wind energy has pros and cons. Our pros are it is a renewable energy source. It has no harmful byproducts, and it's low cost to operate. On the other hand, you guys mentioned that you can't always have wind, and some areas in the world have a lot more wind, some have a lot less. It's not very controllable. The second thing is you can have a lot of accidents in constructing a wind turbine, as well as for the animals. And people get disturbed a lot, you're right, Sharia. So as you can tell, animals and birds, they like to fly and they migrate and they have a specific path and they just go on with their life. And then if you just put a wind turbine in the middle of their path, they might crash into it. Now they may not realize. Yeah, you're right, Jason. So a lot of animals might not like this new addition to their life. And finally, we have noise and vibrations, and just people always mentioning that there's always a background noise no matter what if you live close to a wind turbine. All right, guys, this is the moment where we can all become engineers. We're going to help lift this astronaut up to the top of the rocket using the power of the wind. So we're basically going to create our own wind turbine that is going to help us move an astronaut to the top. Okay, so guys, this is brainstorming ideas part. I need you guys to grab paper, some pencils, draw things out. I definitely draw things out. So please take out paper, pencil, draw things out. Let's talk about this.
I have a question.
Oh yeah, what's up, Jason?
Can it be lined paper?
Yeah, sure, that works. For drawing things out, yeah, line paper can work. If you're gonna use
a windmill out of Lego instead.
I don't make a windmill out of Lego.
Yeah, because I can make one that turns too.
Wow, that's really cool. If you can do that, I would definitely like to see that, Hida. You should do that. Yeah, so you guys might want to take a minute and grab some of these things that I want to say out loud. You might want some paper, a ruler, and pencils to draw your ideas or to create the turbine, the blades. So you can make blades out of these. We need a paper cup to be the lift so that we can actually put the astronaut in it and lift him up. If you don't have a paper cup around, that's okay. You can always create a little box out of paper. If you don't have a Lego man, that's totally normal. So you can just grab coins or anything heavy, any sort of weight. You can even grab like floss or something. Yeah, so you don't have to get all of these. You just have to get some of these, right? So you need something to be your lift. You can create one. You probably need scissors. And you either get a shoebox or a cardboard box or a paper towel or a milk carton, because these are going to be your towers, right? So if you have this could be your tower. The coins are for a weight. So if you want to test it, you want to put something in your elevator, you're going to need to put something in it. but you don't have to have coins. You can just have a heavy eraser. That works too. Grab strings. If you don't have string, you could just use a floss or thread. The tape looks like toilet paper. Okay, good note. And yes, these are some of the things. We're gonna move on to the next slide so that you guys can start generating ideas. So blade design, people. What do you guys think? How many blades do you guys want to put? Everybody can put whatever number of blades they want. Remember the one that we saw in Kenya had, not in Kenya, the one that we saw of Kenya had a lot of blades, and then the one that was your traditional one only had 4. So how many do you guys want? Some ideas that you guys are having. 4, Shakti says 4, okay. I'm definitely on the 4 side because I think that having an even number might make it easier. Yep, I see Meki and Nishi, everybody's saying 4. Cool. And what about the size? I want to make sure my tower actually stands perfectly fine. Okay, you want to make 3 cream? That works. So I want to make sure that whatever my wind turbine blades are, that they are strong enough for the wind, but also that they're proportionate to whatever tower I have. So if my tower is this big, my wind turbine shouldn't be super small and they shouldn't be too big, right? You want to make it balance. Send the materials. Like show you the materials again? Sure. Again, these are whatever materials you guys have at home to make your thing. So yeah, Erin's going to show you guys all the lists of things and then we'll start in a bit. So again, some sort of tower system. A milk carton can work, a cardboard box, a papered roll towel, shoebox. This information is mentioned in the email. So everybody gets a parent communication package and it is there. Tape is just used to connect things together. So if you don't have tape, you can use glue. You could try to tie things together, but I think having tape will be the easiest. Till 9:35, just so you guys can grab the materials because I can see multiple people want the right stuff. So 9:35, and then we'll start building our wind turbines. Anybody have any question or not have one of the materials that they want to talk about so we can like think of ideas? How do we make a tower? Yeah, interesting. So remember when we talked about a turbine, it has to stand on a structure. So your structure could be, remember you want to make sure whatever item you get, it just has to be pierceable. You have to make sure you can poke a hole through it. So like paper towel roll works. If you have cereal box, that works. If you have a granola box, that works. Kareem, you want to turn your camera on? We just ask that, let me see. Thing is, because this is a live session and we do respect everybody's privacy, if you want to turn your camera on, totally up to you. So, yeah. If there's a question, you can definitely ask in the chat. One minute to go, folks, so we're going to start building together. And then, oh, by the way, in the meantime, I'll show you my demo. My demo was really bad. We're not going to create this one, but you know, it'll work. So this is the rocket. This is the turbine. This thing is supposed to spin on the angle. Yeah. I see a question. Jason says, so if you're using a shoebox, do you make a hole in it? So yeah, we're just gonna make a hole. Like as you can see, like your stick has to go through whatever your tower mechanism is. So yes, you do have to make a hole in it, just a tiny one. Yeah, so this thing spins and then there's a rope attached to the bottom of it that starts to twirl And then that elevates this little floss box over here. But don't worry, we'll make a better one. Untwine this now. Wait 5 minutes. This is quite cool. I'm so happy you like it. You need a stick. Yeah, so if you have a pencil or a skewer, that works best. So I would recommend having straws as well. Grab a skewer. So the easiest way to do this would be to grab a straw and a skewer. And then when you put them inside each other, you can create a little axle. So then this thing can spin.
I don't have all the stuff to make the engineer.
But you did say you had a Lego idea, right?
Yeah.
Do you want to try making that, or do you want to try making?
I made the first parts.
I think that was your blade. Cool.
But now I forgot where the Tony thing is. Then box of Legos. Yeah.
Awesome. So let us begin. So first things first, whenever we're designing a solution, we always like to draw things out. This is what I drew. I don't know if you can see it. This is my tower over here. These are going to be my blades, and this is a little skewer, a little axle system, and this is going to hold it in place. And I tried to draw things out. So if you drew things out, that is excellent. What we're going to start off with is, if you have sticky notes or whatever your blades are, you can start creating those. So I have 4 over here. 1, 2, 3. This is 4. What I'm going to do is I'm going to fold them again in half. So take the blade, and I'm folding them in half. So I have rectangular blades. You don't have to have rectangular blades. And this is totally up to you. What I plan to do is have a way to hold my blades together, which will keep it more sturdy. So I'll explain that in just a second. Add materials that are not included in the slide. Yeah, definitely. Make a wind turbine with whatever you guys have at home. That is the whole point. Whatever you can find in your recycling bin. Okay, so these are my 4 blades. They kind of look like that. And I have obviously 2 more. And then I'm gonna grab a straw, and you guys see how on this one, I tried to connect the blades with a straw and I poked it through a skewer. That's kind of what I'm going to create now. I'm going to create the straw part and then attach it to the skewer. So I'm going to make 2 equal size, cut 2 equal pieces of straw. Chris says, I think you meant to say need help. What's up, Kareem? Can you hear me? Yes, okay, you can hear me. And what do you need help with? Can you type your question? Oh, I can see your camera. That works too. And camera just went off. So Kareem, let me know in the chat whatever you need help with. Do the blades. Yeah, okay. So I took sticky notes. I folded them in half. So I literally took like a sticky note out. Yep. You take a sticky note. And you know how there's one sticky side and then there's one not sticky side? You just put them together. You just fold them in half. Make the lines touch. Okay, this one's a little bit wrinkly, but that's okay. Just make the lines touch, and then you're gonna fold them in half one more time so that they look like this. You see that? So this is like, yeah. So Kareem, just one more time, and you do that for 4. Do we need to make sticky note blades? You do not need to make sticky note blades. You can make, I tried to make cardboard blades. I made triangular blades. I just made a mistake. I realized these were 90-degree blades, and it might be better to have blades that are like this rather than just this, because this is a little bit angled. Don't have string, no problem, me neither. So I tried to make this with a thicker type of twine thing. You guys have probably seen this before. This, you can try it, but it didn't really work so well. So what I'm gonna use is either thread, like needle sewing thread, or you can even try using floss because this is like a small model. Floss works too. Any sort of the yarn or anything you can really tie around. Nathan says he's confused. What are you confused about? Nathan, do you have your blades yet? Whatever, the blades, okay. So what do you want to make your blades with? Do you have sticky note blades like me and Kareem? Or do you have cardboard blades? You have sticky notes. So you just take a sticky note. Yeah. Take your sticky note out. Your sticky note's gonna have a sticky side and it's gonna have a not sticky side, and you're just gonna make them touch. So fold it in half. And when you do that, you're gonna have a rectangle. Does that make sense? Yes, awesome. I see Kareem's hand up. What's up? I think Kareem is going to type it in the chat. In the meanwhile, I'm going to take out some pieces of tape so that I can attach my sticky note onto my piece of plastic. Like that. You guys see it? Do I need 4 blades? Yeah, you can have 2 blades if you want, but I think 4 blades would work best. So I am now cutting out my tape and I'm going to put it on straw. Then this end of the straw will attach to the blade so that this sticks together. Yeah. So then it looked like that. And then I'll have another one on the other side. And that will be my plate. Way behind. Nathan, we just started. You just want to take out 4 sticky notes, fold them in half, and then fold them in half again.
Wait, it doesn't say sticky notes.
You're right. So if you have paper, you can do it with paper. If you want to cut out 4 rectangles on a piece of paper and then just fold them in half. I can see Kareem's yellow sticky note blades, which is super cool. Well done. Again, your blades don't have to look like my blades. Like mine are rectangular and like this. But you just have to have some sort of blade. So does everybody have some number of blades ready. Like I have 2 blades here that are just flying around, and then I have 2 blades connected. Kareem, I can see he has 1, 2 blades. Yes. I see Prapti says she, yep. I think it was Mikai says 2. Kareem, I see 3. If you want to make another one, that might be helpful.
Mikai.
Mikai, thank you for correcting me. Mikai says 2 blades. Okay, so 2 blades connected together would look like this. Kareem, if you have 3 blades, it might be a little bit harder. So if you have 4, yep, you do. Perfect. Vladimir made 4 blades. Nathan made 4 blades. Shoria says save. Okay, so now we're going to try to connect our blades. We're going to cut out a piece of straw. Boys and girls, microphones muted, please. Thank you. So we're just going to cut out a piece of straw, 2 equal pieces of straw, and we're going to connect our blades to our straw. So you can tape it, you can try gluing it. I think tape would work better. It doesn't say straw. So if you have pencil or if you have toothpick, try using that. So a small pencil. Actually, don't try a pencil. Can you try to find a straw, maybe? If you have a straw. If you don't have a straw, you could always take a piece of paper and try to roll it and then just tape it together on one side. So I'm going to attach my other blades together. So we're just attaching our blades to a little plastic piece so that they're connected. So when they rotate, they're going to rotate together. Does that make sense, Nathan? We're just connecting our blades. Yes, he said yes. Perfect. So I'm connecting my other blades. You guys start connecting your blades.
So, sorry, I was out to get my toothpicks. Can you like repeat the step again where how you connect them?
Sure. So if you have your piece of toothpick and you have, here, let me show it. So you take your straw or toothpick. Can you see it? Yep. And then you would take your blade and you're just going to put them on top of each other. So you just want your toothpick to be a little bit on your blade, but most of your blade is empty. Can you see that? You just place a piece of tape on it. Does that help?
Yeah.
So here I have blade number 1 and blade number 2 connected with a piece of straw. Blade number 3 and blade number 4 connected with a piece of straw. And when they go on top of each other, they look like your traditional windmill, don't they? Sort of. So this is what we're creating. We're just connecting them. And then when they go on top of each other, they're going to create an X that looks a lot like a windmill. At this point, if you guys can grab a skewer, that would be very helpful. But if you don't have a skewer, a pencil also works. Or something. A pencil or even a pen. And maybe if you could like remove the inside of the pen, you would have like a tube and then something you can insert inside. All right, folks. So we're gonna move on to our axle part. So putting the blades onto an axle. I have my skewer and it is, oops, super pointy, and I can use it to poke through my piece of straw, right? Some of you guys are using toothpicks, so maybe if you put your toothpick pieces together and cover it with tape, could that work? Sure. So I'm just going to continue by putting straw through my skewer so that it looks like this. When I rotate it, it looks a lot like a turbine. You put together your blades properly. I want you to now put your blades onto a skewer. So if you have a skewer like those barbecue stick skewers, or chopsticks, or even a toothpick could work, but a toothpick would be really small. So if you have a skewer, you can stick your plastic, what's this called, straw, through it, and then you'll have nice and drilled into it. And you'll have, when you rotate it, it looks like this. Does that make sense? So just take your skewer and you poke it through your straw. And if you're using toothpicks, then you can do something different. If you're using, okay, I will think of something. Sorry, I give you 1 second. Nahiti, I see your hand up.
I finished my windmill I made out of Lego.
Awesome.
Wait, let me turn off. Let me turn off my background. Actually,
See it? Oh, you actually made it spin. Awesome. Where's the elevator part?
what?
Did you create an elevator to lift the astronaut?
Oh, I even need a person.
You gotta somehow get it to twist up the astronaut.
Oh,
It's a new challenge for you.
I wouldn't even make a rocket. It's like it has to blow the rocket to up.
Okay. So 1 second. I am now going to stick my turbine through whatever your tower was. So this means I'm probably gonna have to take off my straw blades here. But if I remove my straw blades and I poke a hole through my tower somewhere safe. Yes. Okay, there we go. That's 1. That's 2. Have our skewer through our tower. Nathan says, I have a question. What is your question? Nathan, you can type, oh wait, I see your hand up. You can either unmute or type it in the chat. Typing in the chat might be easier. You have 2 questions. Okay. Oh wait, Kareem has a question too. I don't know how to put the 2 axes together. Okay, so do you have a skewer? Do you think you can poke a hole through your thing and have them connected? Yes, so get a skewer, poke a hole through it. And people, we have to create an axle. So we want to create a straw going through our structure here and the skewer going through our structure. So that has a pretty big hole.
Do we have to make an elevator for to the windmill or to the rocket?
To the rocket. So your rocket could be like anything. Yep. Let's see. If you've attached your blades through a toothpick, maybe you can put them together on like use a cotton ball or connect them. You just have to make something that connects the toothpicks together. Okay. We poke the skewer into both. Yes, we poke the skewer into both pieces of straw. Yeah. folks, just a reminder that as I go through this, we're definitely posting this on YouTube, right? So if you want to go back and reflect and think about how this was made, you can do so. But I'm just going to quickly create most of the wind turbine and kind of show you along what I'm doing. So we're just poking straw through our wind turbine's tower. So once the straw goes through, I can put my skewer through it. This creates a little axle. This part can spin. And I can add my blades to one end of the skewer, which is what we did before. And then we can add the other one. Again, if you don't have the materials, it's okay. You can watch for now and then create your own later. So this would like spin like this. I think my plastic piece is a little too big, so I'm just gonna snip the part off. These are all the steps that are shown and some examples that you guys could use. So remember this person's tower, the one on the bottom right, they don't have a tower, they just attached it to their cable. So I could literally take this and attach it to a ledge and then it would spin. And I'm gonna literally call this my little cup here, and this can lift it if it twists and turns. I'm working on the lift part. I just have like a plastic cup and I'm attaching the rope to it. This might be something else. So if you have like something that already looks like an elevator, like this is literally floss attached to a piece of rope. But if you have some sort of weight that you want to lift up, you could do so. Mine rotates really because I tried to create an axle, right? So I tried to create this straw piece and then this part that goes through it, the skewer that goes through it. So both go through the tower. Then to the very end, you can attach whatever your elevator mechanism is and it would go up and down. So that might take a minute. Okay, so this is like a general version of what mine looks like so far. That's my little elevator piece. That's my skewer and straw. And my blades are here. I see Nahida's hand up. I don't know if you just left that open. Awesome. So it is the testing and evaluating part of our presentation. I'm going to show you what I created, but I know not everybody's is done yet. That's totally okay. If you want to check out more in detail how we made the straw and skewer apart, you can rewatch the video. Poke your skewer through your support. Can you please explain it? So I took my skewer and I stuck it through my tower. You can stick it through whatever your cereal box or item is. When you poke it through, you want to make it big enough. So you just take the pointy side and you stick it, you use some strength and you poke it through your paper towel roll, and then you poke it through the other side. But once you do that, you can use scissors. If you have to go, that is totally okay. I'm just going to show you guys what happens when this spins. When this side spins, this part entwines, and then it starts going up and up and up. And that is how it works. But I know for different people, different things happen. And for some people it works, for some people it does not. Does anybody have something that they want to show or discuss about their project? Mine at the end was able to lift some sort of load at the end, but it wasn't really like a cup or anything, so I could work on that part. If you want to test it out, you can either turn the blade with your fingers from the back or push it, or you could use a hair dryer or a fan to blow on it to actually simulate wind. But once it lifts something up, you have basically completed the challenge. And their next steps would be to try to make your designs more sustainable. I do realize that it is past 10 o'clock and some of you guys will have things to do. So we're going to start wrapping it up. Just want to say a big thank you for you guys for coming to our first live learning sessions. Thank you for joining us today in our live learning at home session for 2021 on our topic of wind energy and wind turbines. We hope you'll join us again tomorrow for the same time. And we're going to be talking about another energy source. For individuals watching our live at home learning sessions on YouTube, if you would like to participate and interact with us and ask your questions, you can use the link posted on the screen right now on the slide to register, and registration is still open, so you can still interact with us. Other than that, thank you so much for coming, guys, and I hope you enjoy the rest of your day.
Thank you, everyone. Hope you had a good time today.